example, we're going to consider basically another example of simple oscillatory motion, but this time basically of mass is suspended by a spring. A spring hangs from the initial equilibrium position, gets extended by 1 meter after 100 kilogram mass is hung on this end. What is the period of oscillation for the system if the mass is pulled down a little? So this basically starts out here. This is at some basically y equals 0. I hang a mass to it. This is a distance 1 meter. And I put a mass 100 kilograms. Alright, so let's begin by drawing a force diagram of this object. Okay, so the force diagram of this particular object is that there is a force by gravity, mg, and a counter force, basically F, which is equal to minus ky. Alright, y is going to be about, well, let's just make this thing in the, well, this will be plus ky now, because this is, well, it's minus ky, because this is now y equals minus 1 meter. Okay, so this is going to be 100 times 9.8, which is 980 newtons, which is equal to basically, so that means that the sum of the forces is equal to 0, because it's assuming hanging at rest. So this is going to be basically mg minus f minus, ky, which is equal to minus 980 newtons minus k, which is whatever something we need, times minus 1, which is minus 1 meters. So that means that basically k is equal to 980. Okay, that's right, you write units, newtons per meter. Okay, so that's the first thing we need. Okay, now the second thing we need to remember is that omega, right, the frequency of oscillation for any system, for any spring-driven system, is basically the square root of k over m. Right? For those of you who don't remember why this is true, please go ahead and review your notes or your textbook. Okay, so let's basically calculate this thing out. We can calculate this is basically the square root of 980 over the mass, 100 kilograms, which is now going to be the square root of 9.8. Okay, that's great. Okay, so now take out a trusty calculator. Okay, the square root of 9.8 is equal to 3.1, let's say, radians per second. All right, and the period is going to be 2 pi over omega, which is going to be 2 pi over 3.1. Let's basically invert this answer times 2 times 3.1415, and that is going to be 2.